Okay, thank you for joining me for another installment of Organic Chemistry. Last time we looked at the properties of organic compounds, and today we're going to focus more on the structure of those. What makes organic compounds are that they all contain carbon atoms. Carbon atoms have 4 valence electrons, and so they can make 4 bonds with other atoms. In methane, the one that we looked at last time that we said is the very simplest organic compound, all those all those bonds are with hydrogen atoms. So there's 4 hydrogen atoms bonded with those 4 valence electrons. When you look at this methane here, can you tell me what would the chemical formula be for this methane? We've got the carbon, and then it's bonded to these hydrogens. So, what do you think? Is this what you came up with? CH4? All right, good, because there's 1 carbon and 4 hydrogens. All right, if we make this just a little bit bigger, we could add another carbon, and a carbon can bond with another carbon and have hydrogens around those 2 carbons. So this would be a 2-carbon organic compound. We call molecules like this alkanes. So here we have methane that we saw and ethane. So ethane has 2 carbons surrounded by hydrogens. So what would be the chemical formula for this one? Have you got it? All right. And C2H6, right? All right. If we skip along, we find we could add more carbons. Here we've got propane, and how many? What would be the arrangement here? What's the formula for this one? We got it now? All right. There you are. So C3H8. Do you see patterns in these chemical formulas? What's the relationship between the number of carbons and the number of hydrogens? Do you see it? Okay. Our book would say it like this: CnH 2 times N plus 2, because however many carbons you have twice as many hydrogens plus 2 more. Because if we're looking at these that are straight like this, we've got 1 on top, 1 on bottom, and then 1 on each end of the chain. So now that we see this pattern, what if I had an alkane that is a 4-carbon chain? A 4-carbon straight chain alkane. Do you think you know? All right, let's take a look. Is this what you were picturing? Butane here, C4H10. So butane is the gas that's in a lighter. So you might notice for butane, if you look at a lighter, you can see liquid inside of it. When you look through the plastic inside, you see liquid. But then when you press the button, is it liquid that's coming out? No, it's a gas. And so butane, it has a boiling point that is just a little bit under 0 Celsius. So room temperature is very close to its boiling point. If it's under its boiling point, that means it can stay a liquid. So inside the lighter, if we put just a little bit more pressure on, it will stay a liquid in there. And so that's why it is a liquid inside, but it is a gas once it comes out, because the pressure is released and it's a gas. So back to the formula here. Hopefully this is what we came up with, right? Good. Now for some of these longer chains, they can be arranged in more than one way. So take a look at this one. This one is isobutane. And isobutane has the same number of carbons in it, but they're arranged a little differently. They're not all in one straight line. There's one of them that is connected to the center carbon. So now, what would the formula for isobutane be? Can you figure that one out? So the interesting thing about this is isobutane has the same formula as butane. So we call these isomers because they have the same chemical formula, but those atoms are arranged just a little bit differently. Isobutane is almost like butane, but it just has a little bit different properties, maybe a little different boiling point, a little different melting point. So that is what we have for our isomers. And then if we take a look down here, this is one from our book. We have some 6-carbon alkanes, and they all have the same formula, even though they are arranged in a different order. We do have one that doesn't quite fit this rule, as far as if I'm trying to figure out C6H what? Well, I would say C6H12 plus 2, so H14. But then there is one that doesn't fit, because sometimes these carbons, they can bend around and connect together into a ring. So here we've got carbons all together in a ring, and so these are not going to have the same number of hydrogens, because the hydrogens that should be on the ends here, there's no bonds to hydrogen here. It's just one carbon to the other. So that one will be just a little bit different. Okay. All right, we're just going to look a little bit more here. We've got the alkenes. We will see how they bond together. There's a difference here. You might note that they have some double bonds between the carbons. Carbons can do that. They've got more than one valence electron, so they can make double bonds with each other. That's going to affect how many hydrogens there are connected to these molecules. The names are almost the same. You might see we have ethene, propene, butene, pentene. And so these are going to have less hydrogens on them, because 2 bonds are between the same 2 carbon atoms. So that would make these what we call unsaturated hydrocarbons. Everything we've looked at so far had only single bonds. There were only bonds between carbon and hydrogen and other carbons. They were all single bonds. So those were the alkanes, hydrocarbons with only single bonds. Now these are the alkenes that have a double bond between them. So these will have a little different number of hydrogens, right? They're called unsaturated because they are unsaturated with hydrogen. The ones that are saturated with hydrogen. They have as much hydrogen as they can hold. And then we'll look, we could even have a bigger bond than this. How about this one? The alkynes. This one would be ethyne, HCCH here. So the C2H2. So these also would be unsaturated since they have bonds that are not single bonds. All right. So looking at the ratio of carbon to hydrogen can tell us something about what kind of bonds are in there. Could we get a double bond between carbon and hydrogen? Well, no, because hydrogen only has one valence electron. When it has two valence electrons, it's full, and so it's full once it's made its one bond with carbon. So that's how that's a bit about how we can know about these different hydrocarbons. All right. So now I'd like you to take a look at the assignments that are attached to this and uh, try to complete those, and then let me know what questions you might have. All right. Thank you.